Today's lesson is 4.2, angles and triangles. So in our last lesson, we talked about how we could classify triangles by their angles. Remember, it's an acute triangle if all three angles are acute. It's a right triangle if you have one right angle. It's an obtuse triangle if you have one obtuse angle. And then it's called equiangular triangle if your triangle has three congruent acute angles. We can also classify triangles by their sides. So if all three sides are congruent or the same length, we call that an equilateral triangle. If you have at least two congruent sides, that's an isosceles triangle. And then a scalene triangle is when all three sides are different lengths, so they have no congruent sides. So we're going to move beyond classifying and we're going to talk about the angles inside and outside of a triangle. So when the sides of a polygon are extended, other angles are formed. And so what we mean by extending the sides of a polygon is if I have a triangle, this would be a polygon because it is a closed figure with straight sides. So right now I have angles inside my triangle. I have angle 1, angle 2, and angle 3. If I decide to extend one of the sides of my polygon, I have now created another angle. I have created a fourth angle. Again, if I extend this side, I have now created a fifth angle. And if I were to extend the third side, I have now created a sixth angle. So if you extend the sides of a polygon, you're going to create more angles. So that's all that means. The original angles are the interior angles. So the angles that were original to my polygon, angles 1, 2, and 3, were inside the triangle, so they're called interior angles. The angles that were on the outside that actually formed linear pairs with the interior angles are called exterior angles. So here's what we mean. The lightly shaded red angles that are inside the triangle, those are our interior angles. The ones that are on the exterior are on the outside are called exterior angles. So we have interior angles and exterior angles. So what do we know about the angles in a triangle? Well, our first theorem that we're going to talk about is the triangle sum theorem. So we're talking about the triangle, and sum means that we're adding. And so the sum of the measures of the interior angles. So if I'm going to add all the angles that are inside my triangle, they will always add up to be 180 degrees. So if I take the measure of angle A and I add it to the measure of angle B, so if I take the measure of angle A, I add it to the measure of angle B, and then I add it to the measure of angle C. All three of those angles should always add up to be 180 degrees. We also have the exterior angle theorem, and the exterior angle theorem says that the measure of the exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So I'll explain this one because this is a little bit unique. So angle 1 is our exterior angle because it's on the outside of our triangle. We have three angles inside of our triangle. We have angle A, we have angle B, and we have angle C. So what the exterior angle theorem says is the two angles that are not right next door to the angle outside. So notice angle 1 is on the outside. The way we get the exterior angle is we take the two angles that are not next to it. So that would be angle A and angle B. They are called the remote interior angles. We add those two angles together and that gives us angle 1. So for instance, if I knew that angle 1 was 30 degrees and I knew that angle B was 82 degrees, the way I would get angle 1 is I would take 82 plus 30, and that would be 112 degrees. So angle 1 would be 112 degrees. Then we have the corollary to the triangle sum theorem. So if we know that a triangle always has 180 degrees, If one of those angles is already 90 degrees, that leaves 90 degrees between the last two angles. So angle A and angle B are complementary because angle C is 90. And we know then that 90 plus 90 would give us 180. So that means angle A and angle B together have to be 90 degrees. So we're going to use those examples to, those theorems and corollaries to work out our examples. So it says find the measure of each interior angle of angle ABC. I would always recommend that you draw a picture if there isn't one. So I'm going to draw a picture of ABC. We don't even know what the triangle looks like. So you can draw any triangle that you would like. And you can just name it A, B, and C. So I'm going to name mine A. I'm going to go counterclockwise, B, and C. And then I'm going to label it because I do know some information. It says the measure of angle A is X. So I know that this angle is X degrees. It says angle B is 2X degrees. And angle C is 3X degrees. And so what I've given you are the three interior angles. And so we know that the interior angles always add up to be 180 degrees. So that's exactly what we're going to do. We know that the measure of angle A plus the measure of angle B plus the measure of angle C should always add up to be 180 degrees. So that's what we're going to do. X plus 2X plus 3X should equal 180 degrees. So we're going to combine like terms. 1 plus 2 plus 3 would give me 6X equals 180. And then the opposite of multiplying by 6 would be to divide by 6. And so X would be 30. So we know that X is equal to 30. Then it also asked me to find the measure of angle A, B, and C. So since we know X is 30, we can substitute 30 in for X everywhere that we see. So A is just 30 degrees because A is just equal to X. But B is equal to 2X. So I have to take 2 times X, which is 2 times 30, which will give me 60. So B is 60 degrees. And then we have angle C, which is 3X. So I'm going to take 3 times 30, which would be 90 degrees. So angle C would be 90 degrees. So I had to find X and then substitute X back in. For part B, example B, find the value of X. So again, we have this time a right triangle. I've given you all 3 interior angles. And so we know that all 3 interior angles of a triangle always add up to be 180. So I'm going to take those angles, which are 2X, and I'm going to add that to X minus 6, and I'm going to add that to 90, and all 3 of those should add up to be 180 degrees. So then we're going to combine like terms. We have X and 2X, which would give us 3X. And we also have negative 6 and 90, which would be a positive 84. And then we have a 2-step equation where I'm going to use inverse operations to solve. So we're going to subtract 84 from both sides of our equation. And we get 3X equals 96. And then the opposite of multiplication would be division. And so X would equal 32. Notice the directions just say to find X, so I don't have to substitute anything back in. I would be completely finished with that problem. Example C says find the value of X. This time I did not give you 3 interior angles. I gave you 2 interiors and 1 exterior. So the exterior angle theorem says that if I take the 2 remote interior angles, so the 2 angles inside my triangle that do not touch the exterior angle. If I add those together, it gives me my exterior angle. So I know that if I add J and K together, it should give me my exterior angle, which is angle, we have to call that angle JLM. So if I add X and 70 together, so X plus 70, if I add those two interior angles together, it gives me my exterior angle, which is 2X minus 5. And then we're going to solve for X. I'm going to take my X's to the left by subtracting X. And we get 70 equals X minus 5. And then we're going to undo subtraction with addition. And so X is 75. And then I'm going to look to see if it asks me to just find X or if I have to substitute in. And it said just find the value of X, so we would be finished with 75. Example D, I give you all three interior angles. So we have to remember that when you're given all three interior angles, all three of those angles always add up to be 180 degrees. So we have 2X minus 3. If I add that to 3X minus 15, and I add that to X, all three of those angles should give me 180 degrees. So we're going to combine like terms, 2X, 3X, and X, which is 6X. Negative 3, negative 15 would give me negative 18. And that equals 180. We now have a two-step equation. So to get X by itself, we're going to add 18 to both sides, which is going to leave us with 6X equals 198. We're going to divide both sides by 6. And so X would give us 33. And the directions do just say solve for X or find X. So we would be finished with 33. Okay, again, example E says find the value of X. This is the exterior angles theorem because I gave you two interiors and one exterior. So remember, our exterior angles theorem says the two remote interior angles, which are 40 and 3X, if I add those together, I get the exterior angle, which in this case is 5X minus 10. So I am going to move all my X's to one side. So I'm going to subtract 3X from both sides. And I get 40 equals 2X minus 10. And then I'm going to add 10 to both sides. And I get 50 equals 2X. And then we'll undo multiplication with division to find out that X is 25. And it did just say to find the value of X. So we would stop at X being 25. And then last but not least, we have a multiple choice problem. It says use the diagram to find the value of Y. So if you notice in our problem, we have X's and Y's. And so the first thing we have to do is we have to work with all of the variables that are alike. So if we look in our diagram, we see that we have X's, and I really can only do anything with my X's because I can't mix X's and Y's. So if we look at that, we have one exterior angle and the two remote interior angles. And so what we know about that problem is the two interior angles that you were given, 2X minus 4, and the X. If I add those together, it gives me my exterior angle. So what I'm able to do is I'm able to solve for X first. So 2X plus X would give me 3X. I'm going to choose to move my X's to the right so that my x's stay positive. So I now have -4 equals x minus 47. And then I'm going to add 47 to both sides. And I end up with x being 43. So x is 43. Now, it did not ask me to find x, it asked me to find y. So what I need to do is I need to say, okay, how could I find y? There are actually two ways to do this, so it's however you see it. We could find the interior angles, and we know that interior angles always add up to be 180. Or you can look at the linear pair. I'm going to look at the triangle sum theorem since that's what we've been working with. So if I know that x is 43, I can find how many degrees this angle is because I can take 2 times 43 minus 4. And so if I take 2 times 43, that's going to give me 86. And if I subtract 4 from 86, I know that this angle is 82 degrees. So this angle right here is 82 degrees. I also know that this is just x, and we know that x is 43. So this angle is 43 degrees. So now what I'm able to do is I'm able to say, I know that all 3 of these angles should add up to be 180 degrees. So my 82 degree angle, my 43 degree angle, and my 2y should always add up to be 180. So I'm going to combine my like terms, and I'm going to get 125 plus 2y equals 180. And then we'll subtract 125 from 180. And we get 55 degrees, and half of 55 is going to be 27.5. So y is 27.5, which would be letter B. And so that's how we would find y. So that one was a little bit more involved. So that is how you find values inside or outside of triangles when you're dealing with the angles.